Hi, Assalamualaikum. My name is Nabi Ilman bin Rosli. My matrix number is B0819103339. Today, I will explain for assignment 1, I will explain about question 1.
Okay, this is the question 1. It says that figure 1 below shows a summing amplifier circuit. Determine Vout and current through RF and IRF. So this is the picture for my question, and I will simulate this into this multi-sim. Okay, for calculation question 1, this is the formula that we use to get the voltage, and after we calculate and we get negative 3.572 volt for the voltage, and for the result for calculation and simulation is quite same like the simulation I will give to you after this. For next calculation, we calculate the current for the circuit. So we use this formula, which is IRF equal to V1 over R1 plus V2 over R2 plus V3 over R3 and V4 over R4. So for the V1, V2, V3 and V4 is the V input for the resistor, and the R1, R2, R3 and R4 is the resistor that is 10k, 30k, 33k, 91k and 180k. So after we calculate all this, we can get the negative 0.357 milliampere.
Okay, so this is the simulation part of question 1. So I have built the question exactly from question. So you can see this is the V1, 2 volt, 3 volt, 3 volt also, and 6 volt. This is the R1, R2, R3 and R4 individually 10k, 32, 33k, 91k and 180k. And for the last one, for the RF is 10k. And to measure the output, I have take out the multimeter and the oscilloscope. So let's run the simulation. Okay, I have run the simulation and we click on the multimeter and we put it here and we click on the oscilloscope. Okay, so for the multimeter it shows that I get negative 357.207 microampere, and for the oscilloscope I get negative 3.572 volt. So this is all the simulation for this question 1.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Okay, so my name is Muhammad Imran bin Muhammad Uzaffar. My matrix number is B0819100030. Okay, now I have been given a task to answer question 2 for the title of OMA. Okay, as you can see on the screen, this is the question I have been given. So it said that figure 2 shows a circuit with two LEDs where R is red and G is green. Determine the red and green is on and off for VI equal to 0.5 volts and Vin equal to 1.5 volts. Explain your answer. Okay. From the circuit, as we see on the screen, this circuit is OM comparator. What's the means of comparator? Okay, comparator works by comparing the magnitude of two voltage input and determine which is the largest between them. Okay, here from the equation you can see that Vin have two value. We must put in the circuit. First 0.5 volt and second 1.5 volt. So it says that which one of the value can turn up the red LED, light up the red LED and the green LED. Okay, so we continue. Here is the formula that we can determine which the Vout is positive or negative. Here is if V in voltage input is bigger than voltage reference, then the voltage out equal to positive VCC. And then if V in less than V reference, then V out equal to negative VCC. So if we want to determine which is negative or positive VCC, we must do a calculation. But first, we must find the V reference in the circuit. Okay, so for the V reference, the formula is V reference equal to R2 over R1 plus R2 times by VCC. Okay, so R2 is 2 kilo ohm over 2 kilo ohm plus 2 kilo ohm equal to 4 times with VCC. VCC, as you can see in the diagram, is 2 ohm. So when we calculate, we get the V reference equal to 1. So if we want to know that it is acceptable, I do the calculation. So we have two V in. V in 1 is 0.5, and the second we have to change 1.5 volts. So as we can see that the formula just now, if V in is much bigger than V ref, so it's plus value, right? So 0.5 is less than 1, so it should light up the red LED. Why? Because the structure of the LED diode is upside down, which means it is a reverse bias. So when the value is less than 1, it should light up the red, while the green one doesn't have the reverse bias, just a simple one. It should light up the green when the 1.5 volts is included into the circuit. So from the simulation, we can see that if 0.5, the red LED will light up, and when we use oscilloscope to determine the voltage output, it sets negative 13.587 volt. While when we change the value into the 1.5 volts, the green LED light up, and the voltage output is equal to 13, not negative, 13.897 volt. Therefore, we say that this circuit is a comparator circuit, and the calculation with the simulation is the same. Thank you.
Oh, hi. Now, we're going to be discussing the third question of the set. So, this question, we were given a multiple stages amplifier, and it tells us to 1. Name the type of the amplifier of circuit A1, A2 and A3, and calculate the output voltage of the amplifier V1, V2 and V3. So, for the first question, at A1, based on the construction, we can clearly tell that it's a summing amplifier because there is 2 voltage supply going to one of the input of the amplifier, and the other input is connected to the ground. In this case, the voltage supplies are connected to the negative point of the amplifier, and the positive point is connected to the ground. And at the output, it is channeled back into the input at negative point of the amplifier through a 600k ohm resistor. And here, in A2, we can tell that it's a unity follower amplifier because at one point of the amplifier, there is a voltage supply, and another point is connected directly to the output. Unity follower is particularly easy as the output is the same as the input. And so now for A3. For A3, the construction is exactly as similar as the one in A1, so I can safely say that it is a summing amplifier. I'll repeat again. For A1, it is summing amplifier. A2 is a unity follower or voltage follower, and A3 is a summing amplifier too. And now we're gonna take a look at the second question here. Calculate the output voltage of the amplifier V1, V2 and V3. So first, we're gonna take a look at V1. How to do this? First, we have to consider the output for the first voltage supply by using this formula. Substitute RF value, which is 600k ohm here, and the R1, which is 15k here, and multiply with the voltage supply value, and we'll get this answer. Do the same for the second voltage supply, but exclude the first one like this, and then as it is a summing amplifier, the output that we get from the first one, the output 1 and output 2, is sum up together. That will give us this value. And for unity follower, as I said just now, the output is the same value as the input, so whatever comes in has the same magnitude and value as what comes out. So I can safely say that on V2 the value is negative 22 millivolt. And for V3, first we're gonna take a look at this formula again. It is the same as we did in V1. First, I'll use the voltage supplier that we get from V1 into this formula. For RF, we're going to be using the 300k ohm resistor value, and R3 we're going to be using the 30k ohm value. Ignore the second voltage output here, and the output is 6 volt positive. Do the same for the second voltage input. We're going to be using V2 value for the second voltage input, and for RF it is the same. We're using 300k ohm resistor value and 15k ohm. Do this and you'll get a value of 0.4 volt. And because it is a summing amplifier, we just total up the value of the first one we've got just now, 6 volt, and the second value, which is 0.4 volt. Do this and you get a value of 6.4 volt. And there it is for question 3.